This is 6-6, Properties of Kites and Trapezoids. Try the warm-up problems and hit play when you're ready to see the answers. Okay, so number 1, I got x is plus or minus 5. Remember when we take the square root, it's actually positive or negative. Number 2 is x equals 43. Number 3 is x equals 156. I distributed that 1/4 to both terms to get started. And for number 4, I used Pythagorean theorem, and I got about 19.9, or 6 radical 11 if you simplify the 396. A kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides, as marked up above here. So, oops, that's not a highlighter. That's what I meant. That one and that one's congruent. And we also have BC and CD being congruent. Some other things that you need to know about kites. In kites, diagonals are perpendicular. That's just like in a rhombus, the diagonals were perpendicular. If you have a kite, you have one pair of opposite angles that are congruent. I think of it as the pair that's in between the 1 and the 2 for the congruent marks. So before I even read this question, I know that my diagonals are perpendicular to each other, and my angles in between the two different side measurements, are congruent that I marked there in red. So 18 and 18 is congruent, and these are congruent, 27 and 27, and so therefore these angles are the two that are congruent to each other. Okay, Lucy is framing a kite with wooden dowels. She uses 2 dowels that measures 18 centimeters, 1 dowel that measures 30 centimeters, which is the length of JM, and 2 dowels that measure 27 meters. To complete the kite, she needs a dowel to place along KL. She has a dowel that is 36 centimeters long. About how much wood will she have left over after cutting the last dowel? So basically, what they're asking is for this full length. And we might have to break that into separate right triangles. So here I have my right triangle. And I know that I know the length of JM being 30. And I know it's split in half, since this is an isosceles triangle here. So this is 15 and this is 15. And so then I can use Pythagorean theorem to figure out the length right here and the length right here, and I'd add those together. So for the larger one, I have 15 squared plus b squared equals 27 squared. So let me calculate that. 225 plus b squared equals, I got b is about 22.45. Now let's change the color here, and I'll do my other, the smaller right triangle, which has a hypotenuse of 18. So I've got 15 squared plus b squared equals 18 squared. So that's 225 plus b squared equals 324. So b squared is 99, and b is about 9.95. So that means if I add those two numbers together, the 9.95 plus 22.45, then I get 32.4 centimeters. So how much is left over of the 36 centimeters? So we just take that 36 and subtract 32.4, and so you'd get 3.6 centimeters left over. I'm going to jump right to example 2 just to save some time. So in example 2, in kite ABCD, measure of angle DAB is 54 degrees. DAB is 54 degrees. And measure of CDF is 52 degrees. Find the measure of angle BCD, ABC, and FDA. So I also know that I have a right angle right here. So I'm going to start with that. And then from there, I can calculate. Now keep in mind, since this is an isosceles triangle, this top half of the kite, let me highlight it for you, is an isosceles triangle, then I know that this is also 52 degrees. And I can subtract from 90, which is what, 9, 8 minus 5, 38 degrees for this angle measure. And that makes that 38 degrees as well, same situation. So you can solve that based on that. And then if this is 54 split in half, that makes each of these 27. and my right angles again since the diagonals are perpendicular. And so I can subtract 90 minus 27, 3, 8 minus 2 is 6. So this is 63 degrees, and this is also 63 degrees. So that's how you work out the angles of a kite. And so to answer the actual question, measure of angle BCD, that was 38 and 38, which would be 76 degrees. Measure of angle ABC. ABC, that is, I can't read my writing, 63 and 52. 63 and 52, which is 115 degrees. And measure of angle FDA is 63 degrees. So notice I used isosceles triangles to help me get those angle measures. Okay, in kite EFGH, measure of angle FEJ is 25 degrees. I need my right angles here. That'll help me solve some of these. And measure FEJ, 25. FGJ, this angle right here, is 57 degrees. So I'll have to do a little bit of work to answer this question, but 90 minus 57, well, that's going to be 33 degrees. So this one's 33 degrees. Keep in mind, since FGH is an isosceles triangle, then we'll have 57 here and 33 here. Okay, and so I can probably answer some questions, but I'll just keep going first. So for 25, if I subtract 90 minus 25, what is that, 65? 65 and 25, 80, 90. So 65 degrees here, and it's going to be the same thing here, 65 and 25. So now I can answer whatever they need me to answer here. So GFJ, that's 33 degrees. JFE is 65 degrees. And GHE is 65 plus, I can't read what I wrote, 33 maybe? Looks like 39, but I think I meant 33. So 98 degrees. Okay, now we have to talk about a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Each pair of parallel sides is called a base. This is a lot of vocabulary. The non-parallel sides are called the legs. So the parallel sides are the bases, and the non-parallel sides are called the legs. Base angles of a trapezoid are two consecutive angles whose common side is a base. So the base angles basically hit the bottom. Okay, some theorems that are going to be helpful to us. In an isosceles trapezoid, the base angles are congruent. So for example, angle A is congruent to angle D, and same thing up top, because if you flip this over, it's the parallel sides that are the bases, so you'd have B congruent to C. Trapezoid with a pair of base angles congruent is an isosceles trapezoid. And an isosceles trapezoid has diagonals congruent to each other. So utilizing all that information, we can then calculate. So to find the measure of angle A, well, we know the base angles are congruent to each other. So I'm looking at the parallel side. These base angles are congruent to each other. So that's also 100 degrees. And so then if I know that a quadrilateral contains 360 degrees, and I've used 200 already, that leaves me with 180. And so I did that wrong, 160. So I divide that in half. Let's make that neater. 360 minus 200 is 160. Divided by 2 is 80 degrees each then. So the measure of angle A is equal to 80 degrees. And the next one, KB, is 21.9, and MF is 32.7. And the diagonals are congruent to each other. So if we want FB, well, M to B has to be the same as K to B. So I need to subtract out the 21.9. So 2, 1, 17, 9, 8, 0. 3 minus 2 is 1. So 10.8. 10.8 would be the two parts right here. So FB is equal to 10.8. Okay, for the now you try, my base angles are congruent to each other. So this is 117. So far I've used 234 out of a quadrilateral, which has 360. So I subtract that and I get 6, 2, 1, 126. I cut that in half, and that would be 63. 63 degrees for each of these. So the answer to the measure of angle Y is 63 degrees. Next one, RT is 24.1. So that whole line is 24.1. And QP, that small piece, is 9.6. And we want to know what PS is. Well, since the diagonals are congruent, then it's really like 9.6 plus X equals 24.1. So I'm just subtracting out the piece we used already, the 9.6. 4, 3, 11, 5. 1, 13, 8, 5. What is that, a 9? That's a 9.6. Just kidding. Not 5 then. 4. 4.5. I better double check that math. 13, 14, 24.1, 14.5. I missed the 1. Good thing I checked. 14.5. That makes more sense. Okay, in example 4, applying conditions here. So I have these base angles. Well, I know they're congruent to each other. So a squared plus 27 equals 2a squared minus 54. I can subtract a squared from both sides. While I'm at it, if I want, I can add the 54 to both sides. So that would be 11, 3, 5, 81 is equal to 2 minus 1 is 1a squared. And then to get rid of the squared, I'm going to divide both sides by a. And so a equals plus or minus 9. It's got to be 9 in this case, though. And find the value of a. That's all they want us to do. Okay, so a is 9. Next one, AD is 12x minus 11, and BC, the other diagonal, is 9x minus 2. In order for the trapezoid to be isosceles, those diagonals would have to be equal. So 9x minus 2 equals 12x minus 11. So I can subtract 9x from both sides, and I can even add 11 while I'm at it. So that's gone, that's gone. So I get 9 equals 3x, divide both sides by 3, and so x is 3. I'm going to do the now you try and hit, pause the video, hit play when you're ready for the answer. I got y equals 7 and z equals 15 over 4. Okay, so the mid-segment now. The mid-segment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the length of the bases. So it's 1/2 of the sum of base 1 plus base 2. Okay, so what that means is the midpoint, EF, is equal to 1/2 of 13.5 plus 8. So EF equals 1/2 of 21.5, which is equal to, so EF is equal to 10.75. Okay, for the now you try, what we could do here is the midpoint, ST, which is 31 is equal to 1/2 of ST, which we don't know, plus 38. So 31 equals 1/2 ST plus half of 38, which is 19. Subtract 19 from both sides, and that is 12. 19, 29, 31. 12 equals 1/2 of ST. Divide both sides by 1/2, or you can just multiply by 2. It's the same thing. ST is equal to 24. And this makes sense. If you just think about what's the difference from 31 to 8, well, that's 7. So subtract 7 and you get 24.